All right, so in our previous sections, we looked at vertex or quadratics in standard form. F of x equals a x squared plus bx plus c. We found the vertex, we found the intercepts. In section 5, we're going to look at a different form of a quadratic equation that is what's called vertex form of a quadratic function. So if you have something in what's called vertex form, we write it like this. F of x equals a, so same a to start, but now we write x minus h squared. So we have a single h, and it can be added or subtracted to some h squared plus k. And the important thing about this, in this case, it's where h and k are the vertex. So it's really, really fast to find where the vertex is. So it's always going to be h, which comes after the negative sign, so it's always going to be the opposite of the number you see there, and then k, which is the number on the outside. So very, very simple to graph when you have something in vertex form, because it's really, really, really quick to find the vertex. We can plot this vertex, and just remember that h is the opposite of the sign that's given in the problem. So just a quick example. If I have x minus 3 squared plus 2, my vertex is 3, 2, because the opposite of negative 3 is 3, and then the 2 is just on the outside. Once you have that vertex, which either is going to be the min or the max of your parabola, you can find a couple points on each side of the graph, maybe a couple larger, a couple smaller, and then we have our symmetry to finish up our graph. So, really, really fast way to graph a parabola. So let's go ahead and look at a couple examples. This first one says graph f of x equal 2x plus 4 squared minus 6 by plotting at least 5 points, including the vertex, and adding the axis of symmetry. So if I want my vertex, that's where I'll start. So my vertex, remember, it's always the opposite of what's here. So even though it says plus, what you think is a positive 4, it actually will make the vertex negative 4 for that x part. And then the second part is just whatever's out here. So the vertex is negative 4, 6. It takes some time to get accustomed to this, and we'll eventually call that a transformation. So if we go left 4 and down 6, that's going to be my vertex. Now my a value is 2, so it is positive, so this thing will still open up. So I know the axis of symmetry is just x equal negative 4, because again, remember that first part of the vertex and the axis of symmetry are always the same. So I could draw that invisible line that goes through the vertex if I want. Now, because my vertex is negative 4 and negative 6, so I want to pick a couple values that are bigger than negative 4 for the x. So maybe I pick some easy x. Maybe I pick an x of negative 3. And then I could just put in negative 3 for all the x's, f of negative 3. So what is 2 times negative 3 plus 4 squared minus 6? Negative 3 plus 4 is 1. 1 squared is 1 times 2 is 2. 2 minus 6 is negative 4. So now I know the point negative 3, negative 4 is on my graph. So I go backwards 3, down 4. But then remember, I also know there's another point on the other side. And then I'll pick another x that's bigger. So the next bigger x would be f of negative 2, because negative 2 is bigger than negative 3. 2 times negative 2 plus 4 squared minus 6. This is something you could certainly put in your calculator if you wanted. Just put this all in at once. Otherwise, we got 2 times 2 squared minus 6. It's 8 minus 6, which is 2. So negative 2, 2 is on my graph. So backwards 2, up 2, and then again the corresponding point over here. So now we have plenty of points to show what my parabola looks like. Now, we didn't find x-intercepts or y-intercepts like we did in standard form. We certainly could do that. We could make this into standard form if we wanted to. But to graph it, this is a really, really quick way to do that. Let's look at a couple other examples of graphing a couple more of these. So in this one, our vertex, same idea. It's the opposite of what's in here. So even though it says -1, my vertex is going to be +1. And then whatever's on the outside, which is just going to be 1. So 1, 1 is my vertex. Now if you notice, this says -3, so it does open down. So I pick a couple x's bigger than -1. I could also draw my axis of symmetry, which is x = 1. Go ahead and draw that in. So a number bigger than 1 would be 2. So maybe I do f of 2. So what is -3? 2 minus 1 squared plus 1. Put that in the calculator. Well, that's -3 times 1 plus 1, which is -2. So 2, -2. And then again, corresponding point on the other side. And then another point bigger might be 3. So -3, 3 minus 1 squared plus 1. So that's 2 squared, which is 4. -12 plus 1 is -11. So now we're at 3, -11. So that might be off our graph. Yeah, somewhere way down here. And then another corresponding one over here. So there's my parabola opening down with the proper vertex. Okay, let's look at one more. This one, same idea. Again, we have the opposite inside, so our vertex is going to be that -1 and -3. So left 1, down 3. And then again, we'll pick our axis of symmetry to again be that x = -1. And now we'll pick a couple points bigger and smaller. So a point bigger than -1 would be 0. So we have 0 plus 1 squared minus 3. That's -2. So 0, -2. And again, you could just put these in a calculator. Corresponding point over the axis of symmetry would be there. Next biggest nice number would be 1. You could pick like 1/2 or 1/3, but that just seems like a lot more work. 1 plus 1 squared minus 3 is 2 squared, 4. 4 minus 3 is 1. So 1, 1 is our point. And a corresponding one over there. And so there is my parabola. So just a quick kind of basic idea of how you can use things in vertex form to graph really quickly. Now, eventually, at the second part of these notes that we'll do later, we'll just start to see as we can start to call these transformations. Where you're taking a fixed graph that we start with, and you're trying to move it and change it throughout the coordinate plane by these new functions.